This is in this video we are looking at systems of forces. So systems of forces is the idea that there are multiple things with multiple forces acting on them. Sometimes we have to treat it as one system and sometimes we have to split it up. So in this question it says that a car of mass 1,500 kilograms. So this means that we'll always draw it to make sure we can see what's going on. So you've got a car here of 1,500 kilograms. And that is towing along a caravan of mass 400 kilograms. So that's towing, that's the tow bar. We've got a caravan here of 400 kilograms. So the driving force, which is going to be going this way here, is dN. So I reckon we'll have to work this out at some point. The car experiences an air resistance of 250 newtons. So this car here has, that's a resistance there, 250 newtons. And the trailer experiences air resistance of 120 newtons. So you've got two resistances there. The car and caravan accelerate from rest at 1.8 meters per second squared. So first of all, we have to work out the value of D. And in order to do this, we are going to have to treat it as one system. So that means adding the weights together, adding the resistances together, and that's because the D is the whole system. It's pushing forward the whole system. So therefore, we're going to use F is equal to MA. And F is D minus the resistance. So we've got the two resistance, we've got 250 and 120. That's going to be 370. And that's going to be equal to MA. So the mass here, again we're adding up the masses to get 1,900. And the acceleration of the system is 1.8. So that'd be times by 1.8. So therefore D is going to be equal to 370 plus 1,900 times 1.8. That's equal to 3,790 newtons. Then in part B, we are now looking at the tension in the connection between the car and the caravan. So the tension is this here. That's the tension there. So we're looking for that. So in order to work out the tension, we're going to be treating it just as the caravan. That's the only force we'll be looking at. This we can think. So we're splitting the system up now into just the caravan. So that means that we've got the tension going forward. And what's resisting that is the resistance of a caravan, which is 120 newtons. So that is going to be equal to MA. So the acceleration again is 1.8 because both of them are accelerating at 1.8. That should be times by, and then the mass, now the mass in this one is just 400 because that's the mass of a caravan. That means that tension 1.8 times 400 plus 120, that is equal to 840 newtons. So then the final question in this looks like a SUVAT question. So it says that a driving force is applied for 10 seconds. At that point, the driver puts his foot on the brake and applies a braking force of 2,000 newtons. Calculate how far the car and caravan travel with the brake applied before they come to rest. So for this one, we're going to do two different SUVAT equations. Because first of all, we need to find out the final acceleration in that 10 seconds so that we can work out the initial velocity in the second one. If we look at what we have for the second one already, we know that S, that is what we're trying to find. We're trying to find the distance. Then U, now we're going to find that from finding out V at the first part. That is why we're having to do that first SUVAT. Then V, it comes to rest, so that's going to be 0. A, that is another thing that we need to find. And T is equal to we don't know. And we will never know that. So U and A are the two things that we need to find. So therefore, in order to find U, we're going to set up a SUVAT equation for the first 10 seconds, this is to find V in this one, which is simultaneously U in the other one. So for the first 10 seconds, S, we do not know the displacement. U, it starts from rest, that's going to be 0. V is what we're trying to find. A is 1.8. And T is going to be 10. It's 10 seconds. So therefore, we'll use V is equal to U plus AT. So V is therefore equal to 1.8 times by 10. So V is equal to 18 meters per second. So now we've got 18 meters per second. That is going to be U for this. And now we just need to find out what A is. And to find out what A is, we're going to be using F is equal to MA. So the force here, we're going to treat it again as one system. And it's got a braking force now of 2,000 newtons. So that's an extra, we've got another 2,000 going there. And we also now do not have a driving force anymore. So it's going to be 2,000 newtons plus the resistance. So that means that that is going to be minus, because it's going in the opposite direction, 2,370. And that is going to be equal to MA. So mass is going to be both of them together, 1,900 A. So therefore A in fraction is going to be minus 237 over 190. And we'll keep it like this for now, because that's the most accurate way of putting it. So now we have our A, minus 237 over 190. So now we have everything that we need for this SUVAT equation, so we're going to suddenly put it in. And the one that we do not have is T, so that means that we should be using V squared is equal to U squared plus 2AS. So V squared 0, that's equal to 18 squared, which is 324. And that would be minus 237 over 95 S. And that's times by 2 if you remember. So therefore 324 is equal to 237 over 95S. So to get S, the displacement, we're going to do 324 divided by 237 over 95, which means that S is going to be equal to two significant figures. It's going to be 130 meters. And that is our answer to that one. So the next question is a similar question involving this use of a trailer and towing, and that's our system. So it says that a car is towing a trailer along a straight horizontal road by means of a horizontal tow rope. So the mass of a car is 1,400 kilograms. The mass of a trailer is 700 kilograms. Now the car and the trailer are modelled as particles and the tow rope as a light inextensible string. So the resistances to the motion of the car and the trailer are assumed to be constant and of magnitude 630 newtons and 280 newtons respectively. So the driving force is 2,380 newtons. So first of all, let's draw a picture to depict this information. So we have a car here of 1,400 newtons. 400 kilograms is the mass, sorry. And then we have a trailer of 700 kilograms here. Then we've got this tow rope between this. The driving force is then here, and that is going to be 2,380 newtons. And then resistance here is 630 newtons. And resistance here is going to be 280 newtons. So that is our picture showing what's going on. And then A is asking us to find the acceleration of the car. So for this one, we're going to treat it as a whole system, which means that we've got the driving force of 2,380 minus, and then we're going to add the resistances, so 280 plus 630, and that is equal to ma. So we don't have the acceleration, but the mass, we're going to add that to get 2,100 a. So that means, simplifying this, we're going to get 1,470 is equal to 2,100 a. So then doing 1,470 divided by 2,100, a is going to be 0.7 meters per second squared. So then in B, it asks us to find the tension in the tow rope. And we had a question like this last time, and we know that the tension is this here. That's tension there. So therefore, we're going to treat just the trailer on its own, and we're not going to bother about any of this. So that means that we're going to have T minus 280 as its resistance force is equal to ma. So the mass in this is just 700, and a is equal to 0.7 as we've just worked out. So therefore T is going to equal to 770 newtons. So then it asks us a quick question of state how you've used the assumption that the car and trailer are modelled as particles. And because they are particles, it means that the masses are concentrated at one point. So that means that we can use this idea of a system of forces because the masses are concentrated. So it's just a 1 mark question, and that is all we need to say for that particular mark. Then the final question, which goes back to some more maths, is saying find the distance moved by the car in the first 4 seconds after the tow rope breaks. And this says that when the car and trailer are moving at 12 meters per second, the tow rope breaks. So therefore, I think we're going to be using a SUVAT here again because we have this idea of the 12 meters per second. And then assuming that the driving force on the car and the resistance to motion are unchanged. So therefore, we're going to have S is the thing that we're trying to find. We're trying to find that distance. U is going to be 12 because it says that they're moving at 12 meters per second when the tow rope breaks. Then then V, that is going to be, we do not know that, and we're not going to know that. Then A, now A we're going to need to work out, and T is equal to 4. So A will work out using F equals ma. But again, this time we're just modelling the car. Because the tow ropes break, we do not need to think about this, the trailer, and we will just have the car. So therefore, just the car, we can find out that A, we're going to do 2,380, because that's its driving force, on the whole logic, but then on the car as well. That will be minus 630. That's because we do not need to take into account this resistance here. We only need to take into account the resistance on the car. And that is going to be equal to just the mass of the car, 1,400, that's times by A. So therefore 1,750 is equal to 1,400A, which means that A is equal to 1.25 meters per second squared. So now we have A is 1.25. So now we have our SUVAT equation. We can now put this into the SUVAT, and without V, we're going to use S is equal to UT plus half AT squared. So therefore S is going to be, UT is going to be 4 times 12, 48. then plus half AT squared, that's just going to be 10. So S is equal to 58 meters. So this final system of forces question is slightly different, as we're now looking at a pulley, and we have a mass here of 5 kg, a mass here of 10 kg, and they are connected by a light inextensible string that passes over a smooth pulley at P. So initially A is at rest on a smooth horizontal table, and B hangs freely as shown in the diagram. So you may assume that G is equal to 10 meters per second squared. And this is using some knowledge from the previous two videos, so we have this idea of weight. So going down here, it's going to be 10G. We've also got tension here, and we have tension here, which are going to be the same. And that is how we look at a pulley. So A is asking us to calculate the acceleration of B. Now, in order to calculate the acceleration of B, we're going to have 10G minus T, and that is going to be equal to 10A. But we need to know what T is, and to work out what T is, we don't need an official number here, but we do know that T here is just going to be 5A. As for F equals MA, for this one, we have the F, that's going to be equal to the M is 5 times by acceleration, which means that T is equal to 5A. So we've got mass times acceleration, which is just 5 times acceleration, and that is equal to T, because we have no resisting force on this. There's nothing resisting it. So now we've got that, we can therefore put this as 10G minus 5A is equal to 10A. Therefore 15A is going to be equal to 10G, and it says we can assume that G is equal to 10 meters per second squared, so that we can assume that is 100. Therefore A is going to equal 20 over 3 meters per second squared, which we could round to just 7 newtons. So in B, it asks us to calculate the tension in the string. So this is simple, as we've already worked out that T is equal to 5A, so then T is going to be is equal to 5 times by 20 over 3. That's equal to 100 over 3. Which we could round to 33 newtons for this one. Then for C, it asks us to calculate the velocity of A at this time. So this is a SUVAT question. So we'll put our SUVAT here. Now we do not have S. U, we can find out is U as 0, and that's because it starts at rest. And this, we're just working with A at the moment. We don't need to consider B, but we're just working with A. Then V, that is what we're trying to find out. We're trying to find out the velocity of A at the time. This is after 3 seconds as well. A, well, the velocity thing, that's going to be A, so if you do tension there, tension we have as 100 over 3. So we've got 100 over 3 is equal to 5A. So then we do A is going to be equal to 20 over 3. So A is 20 over 3. And T, well, that's going to be equal to 3. So now we have all of our sections, so we can put that in to V is equal to U plus AT. So therefore V, that's what we're trying to find out, U0, then A times T is going to be 20 over 3 times by 3. Those 3's are just going to cancel out, there. That's going to be equal to 20 meters per second. Then it asks us to calculate the initial height of B above the floor. So that really, because it ends when B hits the floor, we know that its initial height is just going to be the distance that it moves before it hits the floor. So therefore that's going to be another SUVAT equation. But this time we're just trying to work out what S is. So how far it moves in those 3 seconds. So we know that T is going to be 3. We know that A is going to be 20 over 3. So same for what it was for A. It's a system, that's the thing. Then V, it's probably a 0, but we're just going to say no, nothing for that, as we just know, we already know that U is 0. So then S is the thing we're trying to work out. So we have enough things there. So there for this one we'll be using S is equal to UT plus half AT squared. So therefore S is equal to 0 plus half AT squared is equal to half times by 20 over 3 times by 9. So therefore S is equal to 30 meters. So that is the idea of system of forces. Knowing when to split them up and when to use it as one whole force is probably the hardest thing about this. And then obviously we have different concepts in it. We've got the idea of weight in this one, F equals ma, and then SUVAT equations will come in very handy within all of system of forces. So thank you for watching this video and see you soon. Bye.